In this lesson, we're going to solve systems of linear inequalities that are in standard form. Example 1, how do I graph a system of two linear inequalities that are in standard form? So our first example, we have 2x plus 4y is less than 8, and then we have negative 2x plus 3y is equal to 6. So we could graph this in two ways. We could either solve for y and then graph it using the slope-intercept form, or we could graph using the intercepts. For this first one, I'll graph this using the intercept. So I'm going to take the 2x plus 4y is less than 8, and I'm just going to make my little xy table. And I'll take a 0 and a 0. All right, so I'm going to plug in 0. That goes away. Divide by 2. And then x is equal to then 4. So now we'll plug in the 0 for x. That goes away. Divide by 4. And y is equal to 2. All right, so our first one then that we're going to graph is we would start at the 4, 0 for the x-intercept. And then the y-intercept is at 0, 2. And this has got a less than sign. I need to test to see which direction we're going to shade in, but because of that, I know that I have a dashed line. So now let's test a point. So I have this point 0, 0. And if I plug that in, these become zeros. Is 0 less than 8? Yes, 0 is less than 8. So we know that we're going to be shading in this direction. So it would include that solution. All right, so let's graph then the negative 2x plus 3y is greater than 6. All right, and I'll make my little xy table. Whoops. And 0 and 0. All right, so we're going to plug in 0 for y. I divide by a negative. And we're not going to pay attention to this inequality sign at this time. And I'll have negative 3. If I'm solving for y, though, we do. And I'll show you in another example. So now we're going to plug in a 0 for x. That goes away. I divide by 3. And we have 2. All right, so let's maybe graph this in a different color. Let's do this one and this. All right, so we're going to have negative 3, 0. And I have 0, 2. And again, this is a greater than symbol, so I'm going to have my dashed line. All right, so now we need to test that point, 0, 0. Just plug it in over here. 0, that goes away. 0 is 0 greater than 6. And no, 0 is not greater than 6, so we are going to shade in the opposite direction of the 0, 0. So I am going to shade in this direction here. All right, so now notice we have a doubly shaded area. And so I'm going to go make that darker. Is all of this right in here is the solution to this system. All right, so our next one we have x minus 2y is less than 4. And then we have 3x minus y is greater than 6. And really either way, graphing using the intercepts like we did the last one or solving for y is just fine. I think I'm going to solve for y for this one. I have x minus 2y is less than 4. So again, I'm going to solve for y. And then I'm going to divide by a negative. So in this case now, I divided by the negative. I need to flip my sign. And then I have two negatives make a plus. So I have 1 all over 2x. All right, so let's graph this part. So I'm going to start at my negative 2. And I'm going up 1 over 2. And I have a greater than, so I'm going to have that as dashed. And now this one you can use this symbol right here because you've solved for y. You can say, all right, it's greater than, so I know I'm going to shade up. And if you question it, then just plug in the 0, 0. And so for example, if I came back up here and I plugged in a 0 and a 0, or I could have done it with the equation I just had, is 0 less than 4? Yes, 0 is less than 4. And notice how that 0, 0 is in the shaded area. All right, so now I'm going to do the same thing with this inequality right here. I'll take 3x minus y is greater than 6, And again, we're going to solve for the y. Negative y is greater than 6 minus 3x. I'm going to divide by a negative 1. And I just divided by a negative, so we're going to flip our sign. Plus 3x. All right, so now let's go ahead and graph this one. I'm going to start at the negative 6, and I'm going up 3 over 1. All right, and again, it's less than, so I have a dashed line. And it's less than, so it's going to go below the line. So I'm going to shade going down this way. All right, and again, if you question it, plug in 0 and 0. And is 0 greater than 6? No, 0 is not greater than 6, so we had to shade in the opposite direction. All right, so now let's go ahead and find our doubly shaded area, which is right here. And so in this area right here is the solution. So any point that is in that solution, in this shaded area, and not on the line because these are dashed lines, but is a solution to this system. All right, so for our next one, we have 3x plus 2y is less than or equal to 12. So I'm going to use the intercepts for this one. I'm going to go x, y, and 0, and 0. So when y is 0, I divide by 3, and I get 4. All right, and then when x is 0, I divide by 2, and I get 6. All right, so we have the points 4, 0, and 0, 6. And it's less than or equal to, so I need a solid line here. All right, so now we have to determine, because this one we have not solved for y, so we do need to test that point. Let's do this right here. And now I'm going to plug in 0, 0, and is 0 less than or equal to 12? Yes, 0 is less than or equal to 12, so we know that we're going to shade going in this direction here. All right, so now we know that we need to graph. Let's change the color here. We're going to graph this one right here. X is greater than or equal to negative 4. So in every case, x is greater than or equal to negative 4. So remember, the x's are the ones that are going straight up and down. In every case, x is negative 4. And this one, then we're just going to graph, or we're going to shade going this direction. All right, so our doubly shaded area is all of this in here. And on those lines, so any point that you would find in the shaded area or on those lines, those are going to be the solutions to the system. All right, so this one, let's go ahead, let's just use the x and y intercepts again. X, y, and 0, and 0. So I'm plugging in 0 for y, dividing by negative 3, and I get a negative 2. All right, and I'm going to plug in 0 for x, divide by 2, and we have 3. So, all right, so our points are negative 2, 0, and 0, 3. And I know it's solid because it's less than or equal to, so. All right. So now we do need to test this point, 0, 0. So is 0 and 0, is 0 less than or equal to 6? Yes, 0 is less than or equal to 6, so we know that we're going to shade in this direction here. All right, so now we're going to graph this one right here. And again, I think that one's easy just to use. Just get the intercepts here. And again, you can solve for y. Either one's fine for these. So 0 goes away. I divide by 2, and I have 4. And now I'm going to plug in 0 for x. I divide by negative 4, and I end up with a negative 2. All right, so now we've got our points. I have 4, 0. And 0, negative 2. All right, and this is just less than, so I know I'm going to just do a dashed line. All right. All right, so now we need to decide which direction we're going to shade in. So I'm going to plug in this point 0, 0, And this goes away, so is 0 less than 8? Yes, 0 is less than 8. So I am going to shade in the direction of this origin right here. So I'm going to shade going up. All right, so now notice in here we have that doubly shaded area. So this in here is the solution to the system. Any point that you would find in this doubly shaded area, and not on these lines because, or I'm sorry, you could on the solid line. The first line that we graphed was solid. All right. All right, we have 1/2 x minus 2y is greater than 2, and y is less than or equal to 1. I'm going to use the xy table again, and 0 and 0. So when y is equal to 0, we're dividing by 1/2, which is the same thing as multiplying by its reciprocal. So we have 4. All right, and then, all right, and then now we are plugging in x for 0. That goes away. Divide by -2, and I have a -1. All right, so the 2 points we have are 4, 0, and 0, -1, and it is just greater than, so I know I'm just going to do a dashed line. All right, and now we need to determine which direction we're going to shade in. So let's plug in that 0, 0, 0, and 0. Is 0 greater than 2? No, 0 is not greater than 2, so we know we are going to shade in the opposite direction of the origin. All right, for our other one, then we have y is less than or equal to 1. So remember, the y's are the horizontal lines. They're the ones that go through the y-axis, and in every case, y is equal to 1, or less than or equal to 1, I should say. All right, so now we're going to shade going down, and again, we're looking for the doubly shaded area. And so then this area right here and below, anything there and below is going to be the solution to this system. All right, our last example, number 6, we have -4x plus 2y is greater than 12, x is less than or equal to 4, and y is greater than or equal to -3. I'm going to solve for y. So I'm going to add the 4x, and I have 2y is greater than 12 plus 4x divided by 2, and y is greater than 6 plus 2x. All right, so we're going to start at the 6. Oops, and I can't go up to and over 1, so I'm going to go down to -1, because remember, negative is the same thing as positive. All right, so, and it's going to be a dashed line. And now because I did solve for y, I know I can then, it's going to be greater than. So I'm going to be shading in this direction right here. And now let's do the next one. We're going to graph the x is less than or equal to 4. So x, remember x's are the straight up and down, because in every case x is equal to 4. So we're going to go like this. All right. And I'm going to shade in this direction here. Now let's graph this one right here. Y is greater than or equal to -3. Remember, those are the ones where it's a horizontal line, and in every case, y is greater than or equal to -3. All right, so now I'm going to shade up. Now notice we have some doubly shaded, we have some singly shaded. We're looking for the area in which it is shaded by all 3 colors. And so I'm going to come, and it looks like it's from here all the way over and up is the solution to this system. All right, so in this lesson, we took a look at how to solve systems of linear inequalities that are in standard form.